Hey, welcome back to my channel. I'm making a 2D framework using LibGdx. And this video we're going to continue with creating a simple shoot 'em up game. Alright, first thing I want to hit upon is the adding of an obstacle explosion. So let's do that real quick. So we'll add our sound for the explosion. We'll add that to our constructor and set that value. And another update we're going to do to the obstacle is we're going to add a method for setting the obstacle being collided. And so for our movement, which is a script movement, we're going to call the next action. We're going to update our current move motion to 1, which is the red box. We're going to set our destroy to true, and then we're going to play our explosion sound. Then in our handle collision method, if we're not destroyed, we just call our hit method. All right, and another change for that in our obstacle factory, we also need to add the sound to it. We'll add that to our constructor, and then we'll set the explosion. So down in our construct method, where we create our new obstacle, we will add the explosion. And then here in our shoot 'em up screen, we just need to add the sound to this. We get our get sound, and it is called obstacle explosion. Now we're ready to add our enemy ship. And so what we're going to need for that is a kind of a manager class. So we'll create a new enemy manager. And our enemy manager is going to be an updatable. And then we're going to move our obstacle factory into this enemy manager. We'll have our random object here. And since we're dealing with the width a lot, we're going to just create a variable for that. We'll create our constructor. We'll just take the shoot 'em up screen and our obstacle factory. All right, for the width, we're going to get the graphics width, whatever the size of the screen is. We're going to subtract 40. That'll essentially will have 20 pixels on each side. And we'll create our new random object here. And then we'll need to keep track of the obstacle time. And then each iteration, we're going to update our obstacle time with the delta time. And then when the obstacle time is greater than 1 second, we're going to create a new obstacle with the obstacle factory. The x coordinate is going to be a random number of the width plus 20. And then the y is the height plus 20. So it'll be just above the screen. And then we'll reset our obstacle time to 0. And then back in our shoot 'em up screen, we're going to create our enemy manager. And then we'll add that to our updatables in our screen. Now back in our obstacle factory, we no longer need the random in this, and this class no longer needs to be updatable. So we'll get rid of that, and we'll delete the update method. No longer need the current time, and we don't pass in the random here anymore. And random is no longer needed in this class. Another update I'm going to do in our ship is we're going to slow it down just a little bit more. So we're going to make that 2.5. Another update we need to do in the laser class. So when we hit an obstacle and it's not destroyed, we also need to call the other obstacle's hit method so that it's destroyed. So in our laser class, we need to call the factory.spriteRemoved, passing in this so that it gets re-put back into the queue. So now let's get started on setting up our enemy ship. First thing we want to do is be able to move our ship to random locations back and forth so it's not as static. To do that, we're going to update our destination action, and we created an abstract destination action. This contains the common code for our destination actions, which is the goal, the x and y, and the update child method. And this is everything pulled from that destination action update method. And so now our destination action extends that abstract destination action, and our constructor takes in goal and our speed. So we created a random destination action so that we can set our random locations. And so that extends our abstract destination action. And we're going to use a supplier lambda. So that supplier will be able to get a random number. So our constructor takes those two suppliers, x and y, and our speed. And then in the setup method, we'll call our supplier x to get the x location, the supplier y to get our y location. So let's create our enemy object. So here's our enemy ship. We'll just extend the actor. So we'll add our constructor. Now we're going to use the same motion for our still motion and our move motion. We're going to override our handle collision method. We'll implement this in a moment. Back in our enemy manager, we'll need to add our enemy ship. And we're going to add a Boolean flag to keep track of whether or not we added our enemy ship. We'll update our constructor to take the enemy ship, and then we'll just set our enemy ship here. Then we'll need to keep track of the ship time to know when that gets added, because it's going to be different from the obstacle time. So in our update method, we'll update our ship time. So then we'll check to see if the enemy has not been added, and then we'll see if our ship time is greater than, let's say, 10 seconds. We're going to set our enemy ship's location to be just above the screen. So we'll come on the top of the screen. We'll add our enemy ship, and then we'll set our flag to true so that we don't have multiple enemy ships being added. Back in our laser object, we're going to have to add a condition for if we've hit the enemy ship. At this point, we'll just return. And back in our objects, we also need to check to see if the object had hit the enemy ship, because we don't want that to be destroying our objects. And that will just return if it has a collision with the enemy ship. All right, now we need to add our enemy ship to our enemy manager into the game. So our enemy ship, create a new one of those, and it's going to take a movement and a motion. So we need to set those up. So for the motion, we're going to create a block animation just for simplicity. And we'll make it 100 by 40. And we're going to set that color. We'll make it a blue color so it stands out. We'll create our single motion. That just takes our enemy animation. We'll rename that to enemy motion. Now for the movement, we're going to do a script movement. So we got script movement. So that's our enemy movement. Put that in there. And then this guy also takes the enemy ship. Now for that action, we're going to have multiple destinations that we're going to go to. So we have our destination action, and since we actually want to go to random spots when it moves around the screen, so we're going to have a random destination action. And these have a lot of common code, and so we've created this abstract destination action. And another thing that we did, instead of having to require to create a new destination action with each new location, we've now created a list of X and Y goals. And so you can add multiple locations for it to move about. These goals take a type of T. So each subclass of this abstract destination action can define how that next action is retrieved. And so we have our add goal method that takes both the X and the Y of type T. I'll show you how that T works in a moment. And then we have a protected method that gets the next X and gets the next Y, an int and an int. And so what happens here in the setup method, we have our current index, we have our goal X, it's going to equal the next goal X, and then goal Y equals next Y. And so that method will be implemented by the child classes. And then all of this is the same from the destination action originally. This part is new, so we update the current index. We verify that the current index is under our size so that we don't get an index out of bounds. And then we call the get next X, get next Y to get the new X and Y location. And if the current index is the size or greater, then this action is done. So how that works in our destination action, so now the extends the abstract destination action, the type is going to be an integer. And then when we add a goal, it takes an integer X, integer Y, make sure that they're not null, otherwise we throw a null pointer exception. And then the get next X calls goals X dot get, whatever the current index is, and the next Y does goals Y get current index. So now in our random destination action, the abstract destination action type is a supplier of an integer. And then our random destination action takes that supplier integer of X and Y and the speed, and that sets the initial goal X and Y as that supplier. Adding a goal of supplier X and supplier Y adds it to our list. And then the get next X calls the current index to get that supplier, and then we call the get on it to actually return the int value, the X location. And then the Y does the same thing. And I've updated the constructor just now so that the supplier X and supplier Y are both required. So if one is null, it will return a null pointer exception. All right, back in our shoot 'em up screen, we're going to create a random destination action. All right, I filled it out really quick. So supplier 1 just returns 1, supplier 2 is returning 2. So what we need to do is create a random object. So we'll set up a random object. So for our X location, what we're going to do is do random.nextInt, a factor of 10 times 10, give us a lot of distance, and we're going to add 100 to it. So we don't want to be too close to the left edge. For the Y location, we're going to get the graphics, we're going to get the height, we're going to subtract 80 from that, and we'll set up our speed to be 2.5. So that's our first location. Now we'll want to add some additional goals. Now one thing we're going to do is we're going to create a supplier for our height, and we always kind of want to stay at the height of the screen, minus 80 and some random location up and down from that point. And then for the X location, we're going to add another supplier. So he's going to be 10 pixels, a random integer of 10 times 10 from that 10 pixels over on the left side, and then we'll do one for the right side. And so the right will be the width. We're going to subtract 100 and then subtract another 10 times 10 from that. And so what we're going to do is create another random destination action so that it can go back and forth between these 2 points. So the first one will be random left to the random height. 2.5 is our speed. So we'll add a goal of a random right and a random height. Our enemy movement, we're going to add that action to. And then the next thing we need to do in our enemy movement, we're going to add a new action, and we're going to do the go to action so that when it's done, it will go back to that random action and keep doing that over and over again. All right, and let's test that out. So there we have our ship. Obstacles coming down. And then after 10 seconds, there's the ship coming in. And you see now he's going back and forth. And obviously we haven't set up collision for the laser yet, but we'll do that next. So when a ship gets hit, we're going to add some effect to that. So I created a color effects interface. It extends the updatable. It has a method to get the color, and it has a method to tell when it's done, and a reset method so that you can run that color effect again. And I've created a color cycle effect that implements that color effect. It has a base color, which is the color that you start with, so it defaults to white. You have a render color, so it creates a new color that is essentially white. So one thing about the colors and LibGdx, these constant colors, they are mutable, so you can actually change the constant of white to a different color just by changing its internal attributes. So you got to be careful on that. So the render color, I've made a new color. It's white essentially, but it's a different color from this constant white, so that our constant white we're not going to change. And then we're going to have a list of colors and a list of durations. And so each color effect can last a specific duration. We'll have an index for our current color, keep track of our current time, and then we're going to keep track of the current change in the colors. And I'll show you how that works in a moment, and the current duration. So our first constructor takes the color that you're going to change to and the duration that it will take to change to that color. And that calls this add color method. We'll set our current duration to that duration, and then we'll set up our current color change. Our second constructor takes a color that we're going to start with and the color that we're going to go to, and then again, the duration. And that first color gets set to the base color, and then we call the same methods and setups that we did in the previous constructor. Here is our add color cycle method. And what it does is just adds the color and the duration to those two lists. Here we override the get color. We have a render color, so that gets returned. And the is done method, if the current color index is greater or equal to the colors.size, then it's done. reset, we reset our render color to 1 and our current color index to 0. I'm going to bypass the update method for now and step down to this setup current change. And so what this does is it gets the base color, subtracts the color that we're changing to, and it sets those values into this array. In the update method, then we take our current time, we add the delta time to it, and as long as the current time is less than or equal to our current duration, we're going to update our render color. And what the update render color does is it gets the current time divided by the current duration to get our percentage. And so it takes the percentage, times it by that change, and then takes the base color and subtracts that change and sets that to our render color. So then we have our color gradually changing over time. Back in our update method, if we've exceeded our current duration and we fall into this else statement, we update the current color index by 1. And if the color index is less than our color size, then we update our current duration with the new duration. We set our base color to the color of the previous index. Then we set up our current color change, and we set our current time to equal to delta time, and then we update our render color. So now it's starting to cycle to the new color. So to get this to work, I had to update the animation interface. I added a method, set color effect, and then I updated the base animation, added that color effect, and then implemented the set color effect method. And I've added the update method into the base animation. And so that checks to see if the color effect is not null. And if it isn't null, it'll call the color effects update method. And then it will call the set color method to set the color equal to that color effects color. And then it will call this new method update child. And that's an abstract method that's in all of our child classes. So if you remember the motion interface, you can also set colors into the motion class until we've added a set color effect to our motion. So what I've done to implement that is I created a base motion class. This is an abstract class. So all of our motions are going to extend this. And so I've moved in the animations array into this class and the current index. So I moved in all of the methods that are the same in all of these implementations of the motion. And so the get animation checks to make sure you're within the index. Otherwise it returns null. Otherwise it returns that index. Getting the height and width is based off the current animation. Set color, and it will set the color in all of those animations. And the set color effect also sets the color in all those animations. The set size, again, sets that into all of our animations. Set sound and set translucency is the same, setting it in all those animations. So the updates I've added to all of our motion classes, they extend base motion now. Took out the attributes that are now in the base motion. Okay, now we're going to add that color effect to our ship. And we're going to start by creating a new base class for our ship. We'll call that base ship. It's going to extend our actor class. It's going to be an abstract class. And so we're going to have a color cycle effect. That's just going to be our hit effect. And we'll need to keep track of whether or not our ship is hit. We'll create our constructor. Now, since both our ships are different colors, we're going to have to pass in the ship's color. And our hit effect is going to be a new color cycle effect. We're going to start out with the ship's color, and then we're going to make it a color of red. And we're going to do that for 1 second so that we can see it to start out. And then we want to add another color to that. And that's just going to be our ship color. And that's going to be 1 second again. Now we're going to want to add a method for when the ship gets hit. And so if the ship is not hit, we're going to set the hit equal to true. We're going to reset our hit effect just to make sure. And we're going to set our color effect to be our hit effect for both the move motion and our still motion. And since we only have the single object in there, we're just going to use the 0 element. And we'll need to implement our update method. So if the ship is hit and the hit effect is done, we want to set our hit equal to false. This way that the hit effect will only get started once until it's completed, and then you can start it again after it. So if you get hit multiple times, it doesn't constantly restart until it's actually finished the first hit. And then we need to make an update child method. for any updates that the child needs to do. And so that gets called here. We're going to change our ship to extend our base ship. We need to update our call to the super, set our color to white. And then our handle collision, we're going to call the hit method. And now we change our update to update child. We don't need to call the super anymore. And our enemy ship is going to extend our base ship, and his color is blue. And the update child is not going to do anything. Now we need to make an update to our obstacle. And if our other is an instance of a ship and we are not destroyed, we're going to call the ship's hit method. And then we need to also update the laser to hit the other ship. So if it's an instance of an enemy ship, we need to set remove equal to true. And then our enemy ship, we call its hit method. And then the sprite remove to remove this out. All right, let's test that out. We have our ship. Obstacles come down. See, I changed colors when I got hit. When it's destroyed, I don't change colors. I hit my ship there. Change to red and back to blue. And does it again. Now we're going to add a hit counter. So what we're going to do is we're going to create a private variable of an int, call it max hits, and then we're going to have that passed in, max hits, and max hits equals max hits. And then here, when we get hit, we're going to do a max hits, we'll subtract 1, and if our max hits is less than 1, which means it's 0, for now, we're just going to set the remove to true, so our object will just disappear off the screen. So we need to update our ship. Let's call it the super. We'll pass in 10, so we can only get hit 10 times. The enemy ship, we're going to pass in 5, so it can only get hit 5 times. We're going to change our duration of our hit cycle to ½ a second, so it goes faster. Maybe change a little bit faster. Let's do 0.4. And we'll give that a test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's removed. Now we'll test shooting the ship, see if we can hit it 5 times. Here we go. 1, 2, 3, 4, 5, and it's removed. That's how it works. So that's going to do it for this video, and the next video we'll add enemy bullets and have those rain down on our ship. So in the meantime, feel free to subscribe to this video. If you have any comments or questions, put them in the chat below, and we'll talk to you in the next video.